Hey guys, Mr. Backerberg here. In this video we're going to take a look at using absolute value of a real number. When we're talking about absolute value, the absolute value of a real number refers to its magnitude or its size. And we show absolute value by putting a couple of vertical bars around a number. So something like the absolute value of 3 is 3, because 3's size is 3 units. Similarly, if we were looking at something like the absolute value of negative 5, negative 5 is still 5 units big even though it's negative 5. So the absolute value of negative 5 is also 5. Another way that you can think about it is using a number line. Some people like to think about absolute value as the distance away from 0. So again, if we were looking at the absolute value of 3, well 3 is 3 spaces away from 0. And since it's a distance, we refer to it as a positive number. Similarly with the absolute value of negative 5. Well, negative 5 is still 5 spaces away from 0. Again, we're using a positive value there because distances can never be negative. So algebraically, here's how we're going to define the absolute value. This is a piecewise defined function, so it's a function made up of multiple pieces representing the absolute value of some number a. The first piece says that the absolute value of a is just a if that a value is positive, if it's greater than 0. So like when we looked at the absolute value of 3, we got just 3 as our answer. Now the absolute value of 0 is just 0. And then if we look at the absolute value for a negative number, for a values that are less than 0, this negative a actually means the opposite of a. So like when we were looking at the absolute value of negative 5, since our a value is less than 0, then the answer is the opposite of our a value. So here our a value is negative 5, and the opposite of negative 5 is positive 5. So we're going to look at a couple of examples here where we use our definition of absolute value to help us evaluate some expressions. So the first one we're going to look at is the absolute value of 7. Now, looking at our definition, it said if our a value is greater than 0, which in this case it is because we're dealing with 7, if that a value is greater than 0, then our answer is just whatever the a value is. So in this case, the absolute value of 7 is just 7. In our next example, we're going to look at the absolute value of negative 4. Here we've got a negative number, and looking at our definition, if our a value is less than 0, then our answer is the opposite of a. So the opposite of negative 4 is positive 4. Our last example might look a little trickier, but what we're going to look at is the absolute value of pi minus 6. Now, we should remember that pi is about 3.14. So if we take 3.14 and subtract 6 from that, we're going to get a negative answer. So here, as we're evaluating this, because our a value on the inside of our absolute value brackets is actually a negative number, then our answer is going to be the opposite of whatever that a value is, so pi minus 6. Now what we can do here is use our distributive property to distribute this negative into our parentheses, which will give us negative pi plus 6. And then we can rearrange this a little bit. I'm going to flip-flop the 6 and the negative pi, so really we could write this as 6 minus pi. Just a few properties to wrap up our absolute value talk. The first property says that the absolute value of a number is always greater than or equal to 0. When we were talking about absolute value, one of the ways we talked about it was as the distance away from 0, and distances are always positive. So when we take the absolute value of a number, we're always going to get a positive answer, or we could get 0 if our a value was 0. Our next property is that the absolute value of the opposite of a is the exact same answer as the absolute value of just regular a. So like if we were looking at the absolute value of negative 3 compared to the absolute value of positive 3. Each one of those would have a distance of 3 away from 0, so they have the exact same answer. Our third property deals with multiplication inside of some absolute value brackets. What we're allowed to do is we could actually split this up into separate absolute values. So here we've got a times b on the inside of our absolute value. We could split that into the absolute value of a times the absolute value of b, and we would get the exact same answer. Our last property is very, very similar, but it's dealing with division or fractions. So if we have the absolute value of a divided by b, we can split that up as well. So the absolute value of a divided by the absolute value of b, as long as that b value on the bottom is not 0, because you're never allowed to have 0 on the bottom of a fraction. That's going to be it for this video. Thanks for watching.